Okay, so for this example, again, we are trying to determine where the points of discontinuity are. This is very similar to one that we did in class. This is one that we did after school today. So I want to figure out all the points of discontinuity. There are 4 types: oscillating, which we will never see. We have jump discontinuity, which could happen here because it's a piecewise defined function. Then we have infinite and removable. Those happen when the denominator is equal to 0. So that's where I'm going to start. Now I have 2 different pieces. Those pieces don't matter as far as being difficult. We simply look at them each individually. It's 2 problems in one. Buy one, get one. So I'm going to take that first denominator, the denominator of my first piece there, x plus 3, x minus 4, and I'm going to set that denominator equal to 0. In doing so, I will have x plus 3 equals 0. I will have x minus 4 equals 0. And so that tells me that x equals negative 3 and x equals 4 are possible discontinuities. We say possible here because it's a piecewise. If it weren't piecewise, those are definite points of discontinuity. But we have to look at where x is valid for this first piece. X is only valid if it's less than 1. So this x is equal to negative 3 is valid. X is equal to negative 4 is not valid for x is less than 1 because the 4 is not less than 1. And so I don't have to concern myself with that discontinuity. So I only have the one discontinuity, x equals negative 3. So to test to see if that's a discontinuity, I'm going to plug it into the numerator. Again, I'm really taking the limit. What I'm doing is I'm shortcutting this limit by simply seeing what the numerator will be. So if I plug negative 3 into the numerator, I'll have 2 times negative 3 plus 6. And if you work that through, that ends up equaling 0. What this is actually saying is if you were to do the limit of that entire first piece, the numerator and denominator would both be 0. And as we know, 0 over 0 means that we have to play around with the limit, and we are going to get a number for the limit. By definition, a vertical asymptote says the limit has to equal infinity, which we're not going to get. So that tells us we are going to have a removable discontinuity. So x equals negative 3 is a discontinuity, and it is removable. There is one discontinuity. That takes care of the first piece. Now we're going to move on to the second piece. So to do that, we're just going to wipe the work clean here. We'll remember that we have x equals negative 3 as a discontinuity in the end. So wiping that all away. Oh, let's increase the size there. There we go. And now we're going to do the second piece of this piecewise defined function. We're going to look at the denominator of x minus 5 and x minus 7. Again, setting each of those equal to 0. We're setting the whole denominator equal to 0, but by the zero product property, that tells us that either x equals 5 or that x equals 7. Those are both possible discontinuities. Again, possible because it's a piecewise defined function. If I go to that piece says that we are valid when x is greater than 1. Both of these are greater than 1, and so therefore both of these are discontinuities. Now to determine the type. Again, we simply plug into the numerator. We're shortcutting the limit. When I plug 5 into the numerator, 5 minus 5 equals 0, and so because of that, that tells me that x equals 5 is removable because we have a hole there. I'm going to take 7 and plug it into the numerator. If I plug 7 into the numerator, 7 minus 5 equals 2. What that is saying is if I were to do this limit for the bottom part of the function, I would get 2 divided by 0 when I do the limit as x approaches 7. Because 2 divided by 0 is something I can't do, it's undefined, it's infinity, or it's approaching infinity. That's the definition of vertical asymptote. So I have a vertical asymptote here, which means that is an infinite discontinuity. So in the first part, for the first part of the function, we got negative 3 to be a removable. Now we have another 2 other discontinuities. 5 is removable, and 7 is an infinite discontinuity. However, we also have the possibility of a breakpoint because this is a piecewise defined function. So let's take a look at the breakpoint. Now the breakpoint is going to give us a possible jump. So how do I determine if it's a jump or not? Well, I need to look at the limit. I need to look at the limit as x approaches 1 from the left side and the limit as x approaches 1 from the right side. So when I look at the limit as x approaches 1 from the left of my function, I'm plugging 1 into the top piece. And if I plug 1 into the top piece, you can do this relatively quickly in your head. The numerator, 2 times 1 is 2, plus 6 gives me 8. In the denominator, if I plug 1, 1 plus 3 is 4, 1 minus 4 is negative 3, 4 times negative 3 is negative 12. I don't care if you reduce it, that's the limit as x approaches 1 from the left. To do the limit as x approaches 1 from the right, I would use the bottom piece, because that's when x is bigger than 1. So again, I'm just going to plug 1 into that, and so if I plug 1 into the bottom piece, again, I'm just going to go through and talk my way through it. 1 minus 5 is negative 4. In the denominator, 1 minus 5 is negative 4, 1 minus 7 is negative 6, negative 4 times negative 6 is positive 24. If I reduce these fractions, they're not the same fraction. Since they're not the same fraction, what that tells me is the limit from the left side is not the same as the limit from the right side. And since the limit from the left side is not the same as the limit from the right side, x equals 1 is a point of discontinuity and is going to be a jump discontinuity. And so, getting rid of all that work, if I list out my final answer, what my discontinuities are and the types that they are, when we first started the problem, we looked at the first piece, set the denominator equal to 0, and we only got one discontinuity. We got a discontinuity of x equals negative 3, and that was removable. We looked at the second piece. We got x equals positive 5, also removable. We got x equals 7, that was a vertical asymptote, that is infinite. And then finally we got the breakpoint as a discontinuity at x equals 1, that's a jump. And there are your 4 discontinuities for this problem.